How to add arms to Robot PU. Robot PU got his 3D printed arms, and he is thrilled. Look at him go, waving, posing, ready for new adventures. Happiness level, max.
Hi everyone, I'm Coach Hao and this is Robot PU. Today we talk about how to add an external arm to Robot PU. As you can see here, Robot PU, he doesn't have the arm. What we can do is we can 3D print arm, then attach to the construction pin on the back. So at here, as you can see, we add 4 servo to build the arm, 2 for shoulder, 2 for the arm. So in this video, I'm going to show you how to construct the arm and at the same time how to do the programming. Let's detach the arm from Robot PU. Use Tinkercad to construct the servo housing. This is a close lookup of the servo housing. See, this is Lego pin connected to here, and we put 2 servo here. Then we'll build the arm, connect to the shoulder servo, and at here we add another arm servo. So use this 4 servo, we can make Robot PU do it more show time. Let's go to Tinkercad, and there's a PU community there. Go to the PU community activities, back add-ons, and you can see there's a Robot PU arm on back, and tinker this. Then at here you can find Robot PU's arm design, and we also give you a boxing glove. As you can see here, it is the servo housing. So basically it got a Lego pin attached here, and also servo housing. This is a servo. You can put servo inside this house. Okay, and this is the arm. So, and this is the shoulder, and it is the arm servo bracket, and it is another adapter. So this is servo, arm servo, and it is the adapter and to the glove, and this is a glove. So once you print out this piece, and this piece, and glove adapter and the glove, pay attention, the glove left and right, they are not symmetric because the screw here. So you have to print out left arm, right arm, and 1, 2, 3 pieces. Then you will have a boxing arm from Robot PU. It's a boxing arm. Interestingly, so because we have this adapter, and you can design your own stuff. If you don't like the boxing arm, then you can just keep like this. Mount different thing to the robot arm. You can use mount, for example, you can mount a Nerf gun, you can mount a slingshot, so then everything after this is up to you. So you can use this project either to build arm or build a wing. You can do all kinds of cool stuff. And this is the final effect. Now let's compare how do we connect the wire. This is a PCB board we used to build Robot PU's head. As you can see, and on the left side we got 8 servo slots, and Robot PU already use 6 servo slots from S0 to S5. We have 2 extra, 7, 6 we can use to build Robot PU's arm. Since those two pins, they this is a positive, this is a negative, and this blue line, it is a PWN signal lines. The voltage at here is 5 volts, so that means whatever the servo the shoulder servo connect to S6 S7 is powered by 5 volts. um, it's really powerful. And since we run out of the slots for the arm, we have to hijack those signal wires from a microbit. Basically it's pin 14 and pin 15. Unfortunately, those two powers, the power here, it is 3.3 volts. That means if we plug in here, the servo will have much less power. The other way to solve this problem is you have to split your servo connectors to borrow power from here, such that you can still basically use the signal line from here, but use a power line in this 5 volts power source. Basically, this is a layout of our servo connections. Those two servos should use to support shoulder. Those two servos used to support elbow. The reason it is those two pins connect to I2C connected servo. They have 5.5 volts power source, and at here they all directly connect to the microbit. They only have 3.3 volts. So when you plug in the servo, make sure you plug in the right orientation. See, the brown cable should connect to negative, the red is positive, and the yellow should connect to signal pin. And here is the same, negative, positive, and yellow. If you swap it, then the servo won't work. Now let's see how we can connect all the servos. The servo pin 1, 2, 3, 4, 5, 6 belong to the Robot PU's the leg and the head, and the last two, it is the pin we added to here. It's for shoulder. As you can see here, we split the servo into the plug of the servo into two. We connect the 5 volts power from here and use the signal line in pin 14 and 15. Now at here, once you use the Tinkercad, link I post on the description. Then after you 3D print out all the pieces, also do the wiring connections, then it's time to do the programming. You can find this program link in the description area as well. Once you click that, that's the program you're going to see. As usual, you can load the Robot PU extension from the website, pxt Robot PU. So once you do that, then after loaded, you can get a Robot PU's fully extension. The critical one used in this ARM project, it is in the actuators. So we're going to use basically this move command to move robot's arm. And in the on start session, we have to set all the trains of each angle. The purpose of the train, it is sometimes to compensate the servo drifting. At here, we assume there's no servo drifting. All the train value is 0. Then we in the setup, we call servo arm function. In the servo arm function, for example, since like we said in the video before, there are 4 I2C servo pins there, and Robot PU already used 6 of them. Then we have 2 reserve pins for servo, so we call it servo reserve 1 and reserve 2. As you can see here, we move reserve 1 to 90 degree in a rest arm. We remove reserve 2 also to 90 degree. Since we run out of I2C servo. So then we have to use the built-in servo. So you can get it from, which is a microbits default servo commands. Since at here we connect to pin 15 and 14. Then for those two pins, because they are usually has less power, like I was saying in the video, if you don't borrow power from the 5 volts pin power source, then the power it is 3.3 volts, which is weak. So usually shoulder, we put a shoulder in a reserve because shoulder need more power and arm need less power. So that's how we set up. Basically the reserve 1 and reserve 2 is shoulder, and the pin 14 and 15 it is the arm. So once we create this function, so then we increase the robot volume, then we just let the robot sit for 2 seconds. Then we, in a for level loop, we call arm up and arm down. As you can see here, we change the servo angle to different value. We also add one more command, say head pitch. So that means when the robot PU move the arm down, it will lower its head, and when robot PU raise its arm, it will raise its head. At the same time, when robot PU lower its arm, it will say down down down, and when robot PU raise it arm, it will say up up up. So once you do that, you just click download and connect to this code to your the microbit inside robot PU's head, and let's see how robot PU runs this program. Oh, and we add these 2 commands back to enable the gamepad control. Okay, you can. So basically, gamepad will send out a command to robot PU. Robot PU interpret the command. You can get this execute command from the remote control side. Okay, so once we do that, not only the robot PU will keep doing on up and down, but also it will respond to your radio gamepad controller. So if you want to make a robot PU do the boxing, then you have to do some programming here to allow robot PU to do like a punch, 1-2 punch, or some complex like a boxing routine. So be creative.
If you like Robot PU projects, please subscribe our channel. Thank you.
Robot Gyms.